What if I told you there's an engine so powerful that General Motors had to detune it just to keep insurance companies from having a collective heart attack? An engine that, even in its restricted form, still managed to become the highest-rated production power plant ever offered to the American public. This is the story of the 1970 Chevrolet LS6 454, an engine that produced only 450 horsepower, yet shocked the entire automotive world. Picture this, it's 1970, and you're standing in a Chevrolet dealership. The salesman is sweating as he hands you the order sheet for a new Chevrolet SS. His finger trembles as he points to an option code that costs an extra $263.30. That's about $2,000 in today's money for a single engine option. He clears his throat and says, "Sir, I'm legally required to tell you that ordering this engine will likely triple your insurance premiums." That engine? The LS6 454. And here's the kicker. Despite being detuned from its true potential, despite GM's own lawyers begging them not to release it, this 454 cubic inch monster would become the most powerful engine ever officially rated by an American manufacturer during the classic muscle car era. We're talking about an engine that made grown men cry at drag strips, that caused Chrysler engineers to throw their clipboards in frustration, and that Ford executives refused to believe was real until they bought one and tore it apart themselves. The LS6 wasn't just an engine. It was General Motors' middle finger to every competitor who thought they'd caught up. It was Detroit engineering at its absolute peak, consequences be damned. To understand why the LS6 shocked everyone, we need to travel back to 1969. The muscle car wars had reached a fever pitch. Chrysler was dominating NASCAR with their 426 Hemi. Ford was cleaning up in drag racing with their 428 Cobra Jet. Meanwhile, GM was handcuffed by their own corporate policy that limited intermediate cars, like the Chevrolet, to 400 cubic inches. But here's where it gets interesting. In January 1970, GM lifted that restriction. Suddenly, Chevrolet engineers who had been secretly developing big block technology for years could finally unleash their creation. What they'd been working on in the shadows of Detroit's tech centers would make everyone else's best efforts look like economy car engines. The automotive landscape of 1970 was insane by today's standards. Insurance companies were starting to crack down on muscle cars. Ralph Nader's safety crusade was gaining momentum. The EPA was about to introduce emission standards. Everyone knew the party was about to end. So what did Chevrolet do? They decided to build the ultimate going-away present. One last monument to unrestricted American horsepower. The competition was fierce. Chrysler's 426 Hemi was rated at 425 horsepower. Ford's 429 Super Cobra Jet claimed 375. Pontiac's 455 Super Duty was rumored to make 370. These were already ridiculous numbers for street cars. But Chevrolet's engineers looked at those figures and said, "Hold our beer." The problem Chevrolet faced wasn't just building a powerful engine. Any fool with a machine shop could bore out cylinders and make power. The challenge was creating an engine that could survive at maximum output, pass GM's durability requirements, idle smoothly enough to be streetable, and somehow get past the corporate lawyers who were already nervous about liability. They needed to build a sledgehammer that could also pick locks. The foundation of the LS6 started with the existing 454 block, but that's like saying a Formula One car starts with 4 wheels. Everything else was reimagined, re-engineered, and pushed to the absolute limit of what 1970 manufacturing technology could achieve. Let's talk about those legendary rectangular port cylinder heads. While everyone else was still using conventional round ports, Chevrolet's engineers realized that a rectangular design could flow significantly more air while maintaining velocity. The LS6 heads featured massive 2.19-inch intake valves and 1.88-inch exhaust valves. The ports were so large that engineers joked you could mail a letter through them. But size alone doesn't make power. It's all about flow dynamics. The intake ports on the LS6 heads flowed 325 cubic feet per minute on a flow bench. To put that in perspective, a typical high-performance head of the era flowed maybe 250 CFM. The Chrysler Hemi heads that everyone worshipped, they flowed 315 CFM. The LS6 heads moved air like a hurricane. But moving air is only part of the equation. The compression ratio was set at a spine-crushing 11.25.1. In 1970, premium gasoline was rated at 100 octane, sometimes 103 at Sunoco stations. Even with that high-octane fuel, running over 11.1 compression on the street was asking for trouble. Detonation, also called knock or ping, occurs when the air-fuel mixture explodes instead of burning smoothly. At 11.25.1, the LS6 was constantly on the edge of detonation. One tank of bad gas, one hot day with the air conditioning running, and you could scatter $3,000 worth of engine across the interstate. But Chevrolet's engineers had done their homework. The combustion chambers were meticulously designed with a specific quench area that promoted proper flame propagation. The spark plug location was optimized to reduce the distance the flame front had to travel. They even specified a particular heat range spark plug that would self-clean at idle, but not overheat at full throttle. Now here's where the engineering gets really interesting. The LS6 used a mechanical flat-tappet camshaft with solid lifters. No hydraulic cushioning, no automatic adjustment. Solid lifters meant the valve train was always in direct mechanical contact, allowing for more aggressive cam profiles and higher RPM operation. The cam specifications were absolutely radical for a production engine. 0.520-inch lift on both intake and exhaust, with 300 degrees of advertised duration. Let me translate that. The valves were opening over half an inch, and they were staying open for most of the engine's rotation cycle. This created massive overlap, the period when both intake and exhaust valves are open simultaneously. At idle, this made the engine lope like a top-fueled dragster. The idle. Quality was so rough that GM's own service bulletins warned dealers that customers might think something was wrong with their engines. The result? At idle, the LS6 sounded like it was about to stall. Vacuum readings were so low that power brakes barely worked. The engine shook the entire car. But when you mashed the throttle, all that overlap and duration turned into a symphony of power. The engine would scream to 6,500 RPM like it was nothing, pulling harder and harder as the tachometer climbed. Feeding this monster was an aluminum dual-plane intake manifold, part number 3963569. Aluminum was still exotic in 1970. Most performance intakes were cast iron. The LS6's intake saved 40 pounds over iron and dissipated heat better, keeping the incoming air charge cooler and denser. On top sat a massive 800 CFM Holley 4-barrel carburetor, 800 cubic feet per minute. Most street engines needed maybe 600 CFM. The LS6 could swallow every bit of those 800 CFM and ask for more. The rotating assembly was built to NASCAR specifications: forged steel crankshaft, forged steel connecting rods, forged aluminum pistons. These weren't parts that would survive, these were parts that would conquer. The main bearing caps were 4 bolt units, meaning each main bearing was held in place by 4 massive bolts instead of the usual 2. This prevented the crankshaft from literally walking out of the block under extreme loads. The oiling system was equally overbuilt. A high-volume oil pump, a 7-quart oil pan with baffles to prevent oil starvation during hard cornering, and special oil galleries drilled to priority feed the main bearings. Even the oil itself was special. GM specified a particular viscosity and additive package specifically for the LS6. But here's the truly shocking part. Despite all this racing-derived technology, despite the radical cam and massive carburetor, GM rated the LS6 at 450 gross horsepower at 5,600 RPM and 500 pound-feet of torque at 4,000 RPM. Those numbers made it the highest-rated engine ever offered by any manufacturer during the muscle car era. Higher than the Hemi? Higher than the Boss 429? Higher than anything. But wait, there's more. Everyone knew these ratings were conservative. Gross horsepower was measured with no accessories, open exhaust, and optimal timing. Net horsepower, what the engine actually made installed in a car, was typically 15–20% lower. For 1971, when GM switched to net ratings, the LS6 was rated at 425 horsepower, still astronomical. Independent dyno testing told a different story. Hot Rod magazine strapped an LS6 to their engine dynamometer. With just headers and optimal tuning, they saw 550 horsepower. Carcraft recorded 565. Superstock magazine claimed they'd seen 580 from a blueprinted example. The LS6 wasn't making 450 horsepower. It was making whatever you had the guts to extract from it. In the Chevrolet SS, the LS6 turned a relatively heavy intermediate sedan into a straight-line missile. Quarter-mile times were staggering. Hot Rod recorded a 13.12-second pass at 107 miles per hour. That was with street tires that would be considered dangerous today. With slicks and headers, 12-second passes were routine. Some talented drivers saw the 11s. Think about that for a second. This was a car you could buy from a dealership, drive to work Monday through Friday, take grocery shopping on Saturday, and then destroy everything at the drag strip on Sunday. It had a warranty, it had a radio, it had air conditioning if you wanted it, and it would embarrass purpose-built race cars. The LS6 wasn't just about straight-line speed, though that's what it did best. In the Corvette, which got a slightly different version with less aggressive cam timing, the LS6 provided a more balanced performance envelope. The Corvette LS6 was rated at the same 450 horsepower, but felt more refined, more controllable. It could still run mid-13s in the quarter mile, but it could also handle a road course without overheating or oiling issues. But performance came at a price beyond the initial purchase cost. Fuel economy? Single digits, if you were lucky. Oil consumption? A quart every 1,000 miles was considered normal. Spark plug life? 5,000 miles if you babied it. Valve adjustment? Every 3,000 miles or the engine would literally beat itself to death. The LS6 demanded commitment. Insurance companies absolutely despised the LS6. Some refused to cover it at all. Others charged premiums that exceeded the monthly car payment. A 25-year-old male with a clean driving record could expect to pay $3,000 per year to insure an LS6 Chevelle in 1970. That's equivalent to $23,000 today for insurance. The car itself cost about $4,000 fully loaded. Production numbers reflected this reality. Despite the incredible performance, despite being the king of the mountain, Chevrolet built just 4,475 LS6 engines in 1970. Only 3,133 went into Chevelle. The Corvette got 188. El Caminos received 323. A handful ended up in COPO, Central Office Production Order, cars for drag racing homologation. For 1971, the situation got even worse. Compression was dropped to 9.01 to meet unleaded fuel requirements. Power dropped to 425 gross horsepower, though the engine was actually slightly improved in other areas. But the writing was on the wall. Insurance costs were astronomical. The EPA was closing in. GM built just 188 LS6 engines in 1971, all installed in Corvettes. Then it was over. The most powerful production engine America had ever seen was dead after just 2 years. The LS6's impact went far beyond its brief production run. It proved that GM's engineering capability was second to none when the leash came off. It showed that traditional pushrod V8 technology could compete with and beat any exotic overhead cam or hemispherical head design. It established rectangular port heads as the gold standard for big block performance. In racing, the LS6 became legendary. NASCAR teams immediately adopted the heads and basic architecture. drag racers found that the LS6 could easily handle 600-plus horsepower with basic modifications. The rectangular port heads became the foundation for every serious big block build for the next 5 decades. The engineering principles pioneered in the LS6 influenced GM performance engines for generations. The high-flow head design, the aggressive cam profiles, the forged rotating assemblies, these became standard practice for performance applications. Even today's LSX engines, despite sharing only 3 letters with the LS6, follow design philosophies established by that 1970 monster. But perhaps the most significant impact was psychological. The LS6 represented the absolute peak of the original muscle car era. It was the last hurrah before emissions, safety regulations, and insurance companies neutered performance cars for nearly 2 decades. Every engineer who worked on performance cars in the 1970s and 1980s knew what had been possible with the LS6. It became the benchmark, the standard against which all future efforts would be measured. The LS6 also exposed the hypocrisy of horsepower ratings. Everyone in the industry knew that manufacturers were playing games with their numbers. Some underrated engines to avoid insurance issues or NASCAR penalties. Others inflated numbers for marketing purposes. The LS6's conservative 450 horsepower rating, when everyone could see it was making 550 plus, pulled back the curtain on the charade. For collectors today, an LS6-equipped car is the holy grail. A numbers-matching 1970 LS6 Chevrolet can sell for $200,000 to $500,000, depending on condition and documentation. The even rarer 1971 LS6 Corvettes trade for similar money. But here's the thing. Most of these cars were beaten to death in their youth. Finding an unmolested original LS6 is like finding a Rembrandt at a garage sale. The restoration industry has kept the LS6 alive. GM Performance Parts continued producing LS6 blocks and heads well into the 2000s. Every single internal component is available in reproduction. You can build a brand new LS6 today that's actually better than the original, using modern metallurgy and manufacturing techniques. But it won't have that special something that came from knowing you were driving the baddest engine Detroit ever unleashed on the public. There's something beautifully American about the LS6 story. Faced with restrictions, regulations, and corporate hand-wringing, a group of engineers decided to build something magnificent anyway. They knew it would only last a year or two. They knew insurance companies would hate it. They knew it was too much engine for most drivers. They built it anyway. The LS6 represented everything that was glorious and excessive about American automotive engineering at its peak. No overhead cams, no turbochargers, no computer controls. Just cubic inches, compression, and cam timing pushed to the absolute limit of what pump gas could support. It was crude by modern standards, but devastatingly effective. It was the mechanical equivalent of a sledgehammer made from titanium, overwhelming force refined to perfection. Today's engines make more power from less displacement with better fuel economy and lower emissions. A modern Corvette LT6 engine makes 670 horsepower from 5.5 liters. That's impressive, but it doesn't shake the ground at idle. It doesn't require dedication and mechanical sympathy from its owner. It doesn't announce its presence from 3 blocks away. It's better in every measurable way, but it lacks soul. The LS6 had soul in abundance. It was an engine that demanded respect. Start it cold, and it would stumble and cough until the oil warmed up. Get on it too hard with cold tires, and it would swap ends faster than you could say, opposite lock. But treat it right, warm it up properly, feed it good gas and fresh oil, and it would reward you with acceleration that could alter your perception of physics. Modern performance enthusiasts who never experienced the LS6 era might not understand the significance. Today, 450 horsepower is mundane. A Camry makes 300. But in 1970, 450 honest horsepower was earth-shattering. Most cars made 150. A good performance engine made 300. The LS6's 450, really 550, was like showing up to a knife fight with a howitzer. The LS6 also represented the last moment before computers changed everything. This was pure mechanical engineering, no sensors, no fuel injection, no electronic timing control. The carburetor used vacuum and springs to meter fuel. The distributor used weights and springs to advance timing. It was analog engineering at its absolute pinnacle. Every single component had to be perfect because there was no electronic band-aid to compensate for deficiencies. For the engineers who created it, the LS6 was their masterpiece. Guys like Dick Kyneth, who designed the heads, and Sam Weingarten, who developed the cam profiles, knew they were creating something special. They fought corporate bureaucracy, argued with accountants, and pushed manufacturing capabilities to their limits. They won, if only briefly. The LS6 proved that with enough determination, engineering talent, and corporate courage, America could build the ultimate performance engine, not the most sophisticated, not the most efficient, but the most powerful. In the end, that's what mattered in 1970. Raw, unfiltered, brutal power. The LS6 delivered that in quantities that shocked everyone, including the people who built it. As we look back over 5 decades later, the LS6 stands as a monument to a different time. A time when engineers could build something simply because they could. When performance was the only metric that mattered. When a car company would risk lawsuits and insurance backlash to claim the title of most powerful. That time is gone forever, but the LS6 reminds us it once existed. What's the most powerful engine you've ever experienced? Was it modern technology with 4 turbos and hybrid assist, or was it old-school American iron that shook the ground and scorched the pavement? Let me know in the comments below, and don't forget to subscribe for more stories about the engines that changed everything. Until next time, keep those revs high and those tires smoking.